Hey class, this is Gigi. I am going over written assignment 16, problem 1, question E. I think this is a really good problem to look at in terms of power series because it's a little bit involved. So the center here, as you can see, you're supposed to have in a power series the coefficient times x minus a to the k power. But here, instead of having x minus a, you have 4x minus 1. So that could be written or factor out the 4, and that would be x minus 1/4, right? So that would be like, if that was to the k power, this would be to the k power, that could be to the k power. And then this 4 right here could be part of the coefficient. So really is the center is at 1/4, right? Or the shortcut is when is 4x minus 1 0? And that would be when x is 1/4. So your center is 1/4, okay? And then we're asked to find what's the radius. And then we are asked to find what is the interval. Okay, so the interval would go from here to here. And then we would have to check the endpoint when you're looking for interval of convergence. All right, so what are we going to use here? I think I'm going to use the ratio test. That seems appropriate. So we'll do limit as k goes to infinity of, and I have a fraction, so I'm going to plan ahead here, that multiplied by its reciprocal, okay? So this would be 4x minus 1 to the k plus 1 over k plus 1 squared plus 4. Reciprocal of this would be k squared plus 4 over 4x minus 1 to the k power. The 4x minus 1 will divide out, and there is only one copy left, so we'll have the absolute value of 4x minus 1. As far as the k goes, you will have, and then here we'll take the limit as k goes to infinity, and we'll have k squared plus 4 on the numerator. On the denominator, when we expand that out and combine like terms, we'll have k squared plus 2k plus 1 plus 4 is going to be plus 5. This is the part where we have to take the limit of, because that's the ones that are in terms of k. So L'Hopital's rule will apply, and if you mentally do that, you'll get 2k over 2k plus 2, and then you'll do that again, so it'll be 2 over 2, which will give you 1. So the limit here is going to be 1. And so 1 multiplied by absolute value of 4x minus 1 is going to be the same. And what you really want that to do is you want that to be less than 1 in order for the series to converge. Okay, so you want this to be less than 1. So we will say then 4x minus 1 has to be in between 1 and negative 1. That means 4x is going to be in between 2 and 0 when you add the 1 and then divide it by 4. X is going to be in between 0 and 1/2. So this is 0. This is a half. So your radius of conversion is 1/4. Okay. Then in order to find out the interval of convergence, you want to know what is going on here at the end. Okay. So let's take a look when x is 0, and then also when x is 1/2. Okay, So when x is 0, the series that we are looking at is going to be 0 going from 0 to infinity of negative 1 to the k power over k squared plus 4. That looked like an alternating series. So alternating series test will apply. And the alternating series test said, are the a sub k positive? And we say yes, because 1 over k squared plus 4 is positive. Is it decreasing? And we say yes, because if you think about the function, 1 over k squared plus 4, and you're taking the derivative of that, that would be negative 1 over k squared plus 4 squared multiplied by the inside derivative, which would be 2k. Okay, now this k is positive, the denominator is positive, multiplied by negative 1, so it's negative. The derivative is negative, so the function is decreasing. Okay, and then the last thing to confirm is the limit as k goes to infinity of a sub k equal to 0. And the answer is yes, because the limit as k goes to infinity of 1 over k squared plus 4 is 0. So this series converges by the alternating series test. Okay, so we fill in the hole here. We fill in the hole. Okay. And then when x is, so now we'll have to look at when x is 1/2. When x is 1/2, 1/2 multiplied by 4 is going to be 2. 2 minus 1 is going to be 1. So you will just have 1 to the k power, or just 1 over k squared plus 4. Okay, well that looks like a p-series with k equal to 2. So we're going to use a comparison test here. Now we're going to compare it to the series 1 over k squared, which converges, right? So we know that k squared plus 4 is greater than k squared. So when you flip it over, k squared plus 4 is going to be less than 1 over k squared. That condition is met, and the series that you are comparing to converges. So then our series converges by the comparison test. So when we go back here, we would say, hey, I'm going to go ahead and fill in the hole right there as well. So then the interval of convergence is going to be including both ends. Okay, so we would say here the series is centered at a equals 1 over 4. The radius of conversion is 1/4, and then the interval of conversion is including 0 to 1/2, including both ends, and that is the answer to this question. Now, when I first started, I said that this is a really good question. Why is this a really good question? It's a little bit involved, and you have to think about what A is, right? So A is the thing that makes that 0. When is that 0? And that would be 1/4. That's your A right here. And then when we do look for interval of convergence, we end up with two series that we have to use two different tests here to see if it converges or diverges. And that's kind of tied together everything that you have learned before in terms of series to this one, right? So really you're applying three series all in one problem here. And that's pretty awesome. That's So this is a really awesome problem. Okay,